Napoleon walked part of the 60 miles to the side of the battle and rode the rest of the way on a horse. He walked at 3 miles per hour and rode at 9 miles per hour. If the total time of the trip was 8 hours, for how long did he walk? So this is our second visit into the idea of uniform motion problems. The first one, the distance 1 and distance 2 were equal to each other. Now, if you take a look at this, 60 miles to the side of the battle, so we know how far away the battle is. And it says he walked part of the way, and he rode the rest of the way. So he's walking some of the distance, he's riding some of the distance. There's nothing to imply how far he walked and how far he rode was equal to each other. So when we draw a picture of the journey here, this is where he starts. This is where the battle is. He walks part of the way, and he rides a horse the rest of the way. We know the distance from the start to the battle is 60 miles because they told me that in the problem. So when I'm drawing that picture, all I care about is distance. I don't care about how fast he walked, how long he rode and walked. All I care about is distance. He walked part of the way, he rode part of the way, the whole distance is 60 miles. That's all I care about when I draw that picture. His walking distance added to his riding distance is going to equal 60 miles based on this picture. So again, your job in the very first step of this problem, draw a picture of the distance relationship and create an equation based on the distances, because when we get the distances filled in here, we have something to substitute in over there in order to figure something out. So he walked and he rode. Now, once we've established the categories, now I want to care about how fast he went and how much time it took. So, how fast did he walk? He walked at 3 miles per hour. Very good. How fast did he ride?
Not that much faster.
He rode at 9 miles per hour. All right? And the rate's in miles per hour, which tells me time is going to be an hour's distance in miles. So, it's something else that you might want to record in your chart as you're going through what types of units are you dealing with. Okay, now, this is something that's happened a few times already at homework. Hasn't actually been dealt with in a specific example, but I did make mention of it in the first time we visited this. When they give you the total time or the round trip time, how to handle that. And this is how you handle it 100% of the time. You never handle it any differently than this ever. If they say the total time is this, or the round trip time is this, one of the times is t, the other time is total minus t. That's how you handle it. So if they use the words in the problem, the total time was this, one of them is t, the other is 8 minus t, it doesn't matter which one's which. If it says the round trip was this, t is 1, round trip time minus t is the other, every time. There's never a time where you do it differently than that. This highlighted yellow, that's how you handle time. This number is what goes there, put t's everywhere else. Okay? So, once we get our times and our rates set up properly, distance is rate times time, so rate times time is distance, so 3t is his walking distance, 9 times 8 minus t is going to be 72 minus 9t is his riding distance, and his walking distance added to his riding distance equals 60. That's how you fill the chart in every time. I figured out this stuff and this stuff from the words, rate times time equals distance. I've already got the distance relationship set up, so then 3t plus 72 minus 9t is equal to 60. There's my walking distance, there's my riding distance, added up to make 60. I'm going to move the 72 over here to the other side, so I get negative 6t is equal to negative 12. 3t minus 9t is negative 6t. 60 minus 72 is negative 12. In both cases I'm subtracting because the signs are different. In both cases negative because the bigger number is negative. By both sides by negative 6 gets me t equals 2 hours. Notice t is in the time column. The time unit is hours, so that's what t represents is 2 hours. Okay, the final step in every one of these problems is answer the question they ask. And a lot of times people stop here. If the question happened to be, how long did he walk? That's the answer. Okay, how fast, how long, how far. Rate how fast, time how long, distance how far. It says, for how long did he walk? That answers the question, right? The end, 2 hours. For how long did he ride? Time riding is 6 hours. How far did he walk?
6 miles.
6 miles. So his distance walking is 6 miles. How far did he ride?
54.
54. There were 60 miles to the battle, right? So 6 miles walking, distance riding is 54 miles. You could have also put a 2 in there. 72 minus 18 also equals 54. These are all the questions they could have asked me. They asked me this one, so that's the end. But again, there's no assumption of this is the answer to the problem. Always look at the problem, question, and make sure this answers it. If it does, fine. If it doesn't, figure out what it is. Everything that has a letter in it over here is something you don't know. Any one of the things you don't know is something they might ask. So make sure you're answering the question they ask. In this case, this was the question. That's the answer. That's great. But again, all 3 of these questions could have been asked also. So make sure that you're answering the question. I just hate to get to a test, get one of these problems, you do everything perfectly right, you get to here, you get t equals 2 hours, you're perfectly right, but they ask for that answer. And you get it wrong because you didn't answer the question. Even though you know easily enough how to do 2 times 9 and subtract that from 72. It's not hard. Answer the question they asked, not what you thought it was.